All right, so good morning, good evening, good afternoon, and welcome. So whenever you're watching this, hope this reaches you guys well. So today we're talking about solving quadratic equations by graphing. This is a very Desmos heavy lesson. So please make sure you have a separate tab open to Desmos, that's DESMOS.com. All right, so we've been talking about solving quadratics by factoring, by doing all sorts of different things. And now we're going to use graphs. On the lessons today, on the notes, if you don't have the notes for 9-3, please come see me in class and get them, or you can go on Canvas, and I should have them up by now. It's been kind of a long weekend, and so I didn't put up a lot of stuff, so I apologize for that. Solutions. So when solutions are the x equals, so we've been solving these, we've been getting x equals something and something else, okay? That's if there's two solutions. You get x equals something. If there's one, it would be x equals one solution. And if there's no solutions, that means when you enter it into Desmos, you wouldn't actually get an answer because you're looking to solve for x. And remember, usually it's x squared plus bx plus c, and that's an a in front of that. And that's our main setup, okay? And so knowing that aspect of it, you guys know that if this is what we're looking for with the value of x, it's trying to find the answers, okay? All right, so let's begin. First and foremost, solve each one by graphing. So if you go into Desmos and you would enter this equation, I already have it set up because I want to go pretty quickly with this lesson. And so in Desmos, my number one on the board, if you guys have it, okay, if you put it in like it sits, equals 0, ladies and gentlemen, you should get 2 lines. Okay, these lines are parallel. These are solutions. We had talked about before in class how when we first started solving multi-step equations, you could enter an equation in like this, set it to 0, and you would actually get an answer, and the answer would just be one solid line. Well, in this case, it's actually 2 solid lines, okay? -2 and 5. Now, one aspect of when you're looking at this, you might think, well, that's weird. Well, it's because we set it to 0. If we do not set it to 0 and we just enter it like it is, you actually get the parabola. So I will back it out. You get the same answer, but you actually get to see the parabola that goes along with it. So I would recommend in this lesson that if you can, don't set it to 0 to kind of get the shape. So our answers are -2 and 5. In class, I had students also write down one other thing. This is when you want to solve. When you solve, this is the answer you would get. If I were to ask you to factor this equation, okay, you guys would set up the x. Some of you have -10 and -3, and then you would solve accordingly. But you can actually use it by, you can actually solve using the answers that you get. And the answers would be, of course, an x and 2, an x and a 5. But the question becomes is, what are the signs? Well, they're actually going to be the opposite of what is here. Okay, the reason is -2 plus 2 is what? 0. 5 minus 5 is 0. So going forward, if I ask you guys to factor something out, okay, you could technically factor it out by using Desmos. But one thing you got to make sure is that if your answer is a -2, 5, that you would use the opposite to factor. So today, we talked a lot about using solve. So it's x equals, and then factor. And factoring would be these two setups, okay, equals 0. So let's enter this. Now this one isn't set up. If I turn this off and turn that one on, ladies and gentlemen, I will get 2 lines because this is not set up as a perfect trinomial. If I wanted to see the parabola with it, I'd have to move this -6x and add it to both sides, and you get your equation. But it doesn't matter because I get my answers of -1 and 4. So I know my answers are -1 and 4. So my solution here would be x plus 1 and x minus 4. All right, ladies and gentlemen, I want you to try these two real quick. All right, in relation to these, same setup, guys. So it's going to be x equals, and then I want the factoring, x equals, and then I do want your 2 factors. All right, so my second one here, it's going to be the one with plus 18. The setup is -6 and 3. So my x's are -6 and 3, which means x plus 6, x minus 3. Do the next one here. 2x squared minus 4x plus 3. My x's are 1 and 3. So on here, if it's 1 and 3, this would be x minus 3, x minus 1. Sorry I wrote it backwards, but it doesn't matter how you write it. Always remember that. All right, going forward, now we're going to talk about a double root. And what is a double root? Well, ladies and gentlemen, when we graph it, we'll find out. We're still going to get an x equals, and we will still get this setup. All right, same here, x equals, and then it's still going to be, I want to see the factoring setup. So on x equals, the next one, x squared plus 6x minus 9. If you draw that out, you guys can see the black line that appears. Okay, let me go hit the home button, zoom in a little bit. When you guys see the black line that appears, what happens is, what if I actually rewrite it as a trinomial? So it's equals negative 9. What if I add 9 to both sides and write the equation like this? Well, you would actually get the parabola, which there it is. It's set up like this. Okay, so it's 1 point at negative 3. And so your answer here is going to be x equals negative 3. But then remember, we need to have 2 of these. So what is the setup going to be here? Well, as a matter of fact, it's the same thing. Okay, it's going to be plus and plus. So another way to write it would be x plus 3 squared. All right? If you guys, when in doubt, if you rewrite this and add 9 to both sides, okay, you do your x, you get a 9 up here and a 6 down here. So what two terms multiply together to get 9 when you add them are 6, are of course 3. And so that, ladies and gentlemen, is why you get that answer. So hopefully you guys understand that when you graph this one, you're going to get x equals, you're going to get x equals 2. So I know on this, it's going to be x equals 2. And your setup is going to be x minus 2 and x minus 2 equals 0. Now, technically speaking, there's a negative in front of here. So if I were to ask you to factor this out, and we haven't talked too much about negatives, technically you would factor out a negative and then you would multiply it across the board. But I'm not too concerned about that at this point. I just want to make sure you guys understand the setup. Okay? If you want to know why it's a negative, multiply this out. What would you get? You get positive x squared. Is that what we have? No, we have a negative x squared. So you'd have to actually factor out a negative first, then you'd solve accordingly. Okay, now what we're going to do is on the guided practice, you guys go ahead and go for it. All right, if you were to graph this, I know this would be a negative 10x. So if you were to graph it, you would get x equals negative 5. Or excuse me, you would get x equals 5. Because your setup here needs to be x minus 5, x minus 5. All right, this one here, you would add everything to one side, so x would equal negative 4, because I need x plus 4 and x plus 4 to be the answer. If you doubt this, please graph it if you haven't already, and you'll see the answer. Next, solve each of these equations by graphing with no real roots. Okay, so what we're going to have here when we graph these is we're going to see a different type of graph. So if I were to graph this out, here's my graph. Okay. Now, if I put what's in the book where it says equals 0, what happens to the equation? It's actually gone. You could zoom out to 1,000,000. It's not going to show up. Why? Because x can never equal 0 in this equation. And the reason it can't equal 0 is because when you graph it, the lowest point it goes is negative 1, 2. So in class today, I want to make sure you guys understand that this is no solution. There is no x, okay? But what we did do is we did write the vertex down, because I want to get you guys practice on the vertex. So on your notes, your vertex would be negative 1, 2. All right, this one here, I already know it's going to be no solution. When you graph it, you guys would see why in a second. But the actual 2x squared minus 3x plus 5, here's my setup right here. And my vertex is 0.75. And then 3.875. All right? Any questions on that? The reason there's no solution is because the graph doesn't come down and touch the line. All right, your guys' turn. All right, when you guys do these, make sure you graph them accordingly, okay? I already know this is going to be no solution, and so is this. The question is, what is the vertex? Now, am I going to ask you this on a test? No. The reason I wanted everybody to find the vertex is to kind of get used to that. Okay, I need to make sure you guys can actually find these things. So negative 2x squared plus 3x and 5. My vertex is 1.5 and 2.75, so negative 1.5, negative 2.75. There's your vertex, and the vertex here is going to be, whoops, if I turn that one off and on, it's going to be negative 1.5 and negative 3.5. Okay, so that's a simple setup on there. All right, if you guys have any questions for me, please make sure you ask, but remember, because it doesn't cross the x-axis, there is no solution and there's no way that you're going to have x. All right, so now we talked about approximating roots with a table. One thing we had talked about in here is that on Galileo, we've already had a question similar to this. And on Galileo, there was a table set up. And sorry, I'm drawing it really weird. It was 0, 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth. And the question was asked, when you graph this, the intersections are between what two numbers? So let's graph this real quick. All right, if we graph this particular one, x squared, when you set it up, you get an approximation point. So your approximation point is 0.586. So on Galileo, and if for all of you that don't remember, Galileo is what we're going to use on the final, okay? It's going to ask you, this point falls between what two whole numbers? And of course, the answer would be what? 0 and 1. For this point, it would be 3 and 4. Just please make sure you guys understand that. So what you would do on the test is you would highlight 0 and 1, and you highlight 3 and 4. And so that would be how you do it. But for today, just know that x is approximately 5.86, goes to the nearest tenth. So it's 0.6 and 3.4. Those are approximations. All right, ladies and gentlemen, graph this real quick. Go from there. So this one is going to be x is approximately, if you close that down, let me turn the graph on. It is approximately negative 3.4 and 0.4. Is it positive or negative? I didn't see that part. Positive. Okay, so there's your answers. All right, so hopefully you guys understand. Just graph it, round it to the nearest tenth. All right, Consuela built a model rocket for a science project. Here's the equation. All right, it wants to know how long was Consuela's rocket in the air. So all you would do is go into Desmos and type in this equation, and here it is right here. So this equation, it has a high arc. So do we see anything? It looks just like a line. So please don't say, well, I don't see anything. Zoom out, okay? So I'm going to zoom out quite a bit here because I want to show you guys one thing about Consuela's rocket. All right, so when I zoom out, hopefully you guys can see the gap still. So her rocket left at 0, 0. It reached a vertical height. So remember, if we were to ask you what is the height that she reached, it'd be 976.5 feet. And then how long did it take to get there? It'd be 7.8 seconds. But that wasn't the question. The question was, is how long was it in the air for? Well, it went up, it came back down, and it was in the air for 15.6 seconds. So make sure you guys can answer these. The reason I told you all that extra stuff is so that you guys can understand and interpret these graphs, okay? That's a huge thing going forward. Guided practice is just this top one. Please work on that one real quick. All right, and so with this one, you just graph it. You can change Consuela's numbers here to 120. So let me zoom into home. And it'd be 120. And this one you can actually see the x comes back down 7.5. Okay, it doesn't say how long it goes, it just says how long it was in the air, 7.5 seconds. Hold on, let me write that. 7.5 seconds. That's better. That looked like double fives. Okay. Now the last piece of this was talking about a goalie kicks a soccer ball. When I was in high school, we used to shoot rockets. For everybody that is not fully aware, sports is now going to analytics, which talks about like launch angles, rate of acceleration, all sorts of crazy stuff in baseball. And I'm pretty sure football will follow that soon with some analytics, trying to see what plays work well. And soccer will use it. There's all bunch of sports. Hockey will definitely use analytics, trying to figure out what the best way is to put your players in the best position to win. So what you would do is you would graph this equation, and then it asks how long was the ball in the air. And that's all it asks for. So if you graph this equation, let me make sure I have the numbers set up here correctly, because I don't. It's 65, and it said it was off the ground by +1. Make sure I have the right setup. 65x. Now this says t, but remember you can't put t in Desmos and get an answer. You got to change that to actual x. So if you plug it in and graph it, ladies and gentlemen, you can see that the ball was in the air for about 4.1 seconds. And then if the goalie kicks a soccer ball with an upward velocity of 55 feet and 2 feet off the ground, how long will the ball be in the air? So you just come here and you would change your answer on Desmos. So instead of 65, it'd be 55. Instead of 1, this would be a 2, because that's what those numbers represented if you read the proper equation. The ball would be in the air for 3.47 or 3.5 seconds. So ladies and gentlemen, that is it, okay? One key aspect as we went forward is making sure you guys understand the process of solving these in Desmos and then converting them into the factored form. There's a complication when it comes with an A value. And I did show students in class, okay? But know that sometimes if you have an A value, it's a little bit more complicated. And there was this example of 3x squared negative 8x. If you want to know how to actually interpret this answer, because you can't actually put this number into your setup, okay? This is an answer, but you can't factor it or write an easy factor unless you know a couple tricks. If you have any questions for me, please come see me. This is a relatively quick lesson. Use this information to answer the questions faster. And then understand you could also use this to double check your factoring work, okay? And if you do have any questions though, come see me. Remember, homework is back open. And in the meantime, ladies and gentlemen, I look forward to seeing you again in class. But if you need anything from me, please shoot me an email or send me a message on Remind. But have a great evening, guys.